So hey guys, welcome to our YouTube channel. So this is the video series of Astronomy and Astrophysics. From the last few videos, we have started the new chapter known as the Sun, and this is video number 9. And in this video, we are going to cover solar wind, Van Allen radiation belt, solar activity, sunspot, and a few other things. So if you have any suggestion, comments, requirement, you can mail us on our email ID. Our email ID is ade2026@gmail.com. So let's start the video. So the sun's outer atmosphere, which is known as the solar corona, extends much beyond into the space. The outer layer of this solar atmosphere, in fact, continuously emits charged particles, which fill the entire solar system. And this emission is called as the solar wind. It comprises streams of charged particles consisting of mainly protons and electrons, and causes continuous loss of mass from the sun. As both the protons and electrons have their masses, so they continuously lost the solar mass. The phenomenon of solar wind was predicted much before its detection, and its characteristics can be investigated using cellulars. For instance, the solar wind velocities range from 200 to 700 km per second at the distance of the Earth from the Sun, and the number density of solar wind at this distance is nearly about 7 particles per centimeter cube. Now you may ask a question that what causes the solar wind? So due to high temperature prevailing in the corona, the gas content therein exerts tremendous pressure outward. In fact, the pressure is much higher than the inward pressure due to the sun's gravity. The gas therefore streams outward from the sun, and so the electrically charged particles carried by the solar wind cannot cross the lines of force of the Earth's magnetic field. As you know that our Earth has a strong magnetic field. So they spiral around the field lines and move back and forth between the two poles of the Earth. As a result, two donut-shaped zones of highly energetic charged particles are created around the Earth, and they are collectively called the Bell Allen radiation belt. So this is the diagram of Bell Allen radiation belt. So the charged particles, due to the Earth's strong magnetic field, cannot penetrate into the Earth's atmosphere. So they just oscillate between the two poles of our Earth. So this is inner radiation belt, and this is outer radiation belt, and collectively this is known as Bell Allen radiation belt. Now let's discuss solar activity. So astronomers have observed a variety of short-lived events, collectively known as solar activity, occurring on or near the surface of the sun. The root cause of all these activities is the existence of strong and localized magnetic fields in the photosphere, which is the sun's surface layer. Studies of this event or activities provide valuable information about the sun and the nature of its magnetic field. So sunspot, which is one of the solar activities. So if you look at the photograph of the sun, we see dark spots on its visible surface, and these dark spots are called sunspot. Sunspot can be seen sometimes even with an unaided eye at sunrise or sunset. The sunspot temperature is nearly about 4000 Kelvin, and with such high temperature, they appear black because they are relatively cooler than their surrounding areas in the photosphere that have an effective temperature of near about 6000 Kelvin. So this is the figure of sunspot. Here you can see these black spots on the surface of the sun, and these black spots are known as sunspot. So this is the uh, schematic diagram of sunspot. So the central dark region of the sunspot is known as umbra, and the outer boundary, that is the less dark region at the boundary, is known as penumbra. So this is the diagram of sunspot. So now you may ask a question that why is the temperature of the sunspot lower than their surrounding? So it is due to the existence of strong magnetic fields in the sunspot. In the presence of a magnetic field, a spectral line emitted by an atom at a single wavelength is split into three lines, and this is called the Zeeman effect. Such Zeeman splitting is also observed in the spectrum of sunspot. Since the line spectrum del lambda is proportional to the applied magnetic field, a magnetic field up to near about 3000 Gauss has been estimated in sunspot. And the presence of strong magnetic fields in the sunspot restrains the flow of hot material from layers below the photosphere. Therefore, within a sunspot, the magnetic field is quite intense, which is nearly about 3000 Gauss, and that is the boundary of the sunspot, the outer boundary of the sunspot. So, this field strength in the penumbra is estimated to be about 1000 Gauss. So, how do this cooler region, that is the sunspot, survive for so long with the outer hotter region? So, this could happen due to the sun's magnetic field. We know that the magnetic field exerts a pressure which is equal to B square by 2h mu, or B is the magnetic field intensity across the lines of force. This pressure along with the pressure of material inside a sunspot balance the material pressure outside and the sunspot can exist in equilibrium. So this is for today's video. We hope that you have understood it. And if you have any suggestion comments, you can write in the. Also, if you are interested in documentary type videos of physics, then we have also a channel in which we make documentary type videos related to physics and science. The name of the channel is Debreak, and we will give the link of this channel in the comment section. You can visit our channel. Thank you for watching this video.